Hello everyone. Today we're going to be reviewing derivatives. When we started our unit on derivatives in the classroom, we started with the average rate of change versus the instantaneous rate of change. We said the average rate of change was the slope of a secant line, or f of x minus f of c over x minus c, where the instantaneous rate of change is the slope of the tangent line to a function at a given point. And just real quickly, I want to refresh your memory on the two ways we can visualize this. The average rate of change, slope of a secant line, right? We have the 2 points, our line, and we find that by evaluating f of b minus f of a over b minus a. And over here, okay, what we did was we brought our 2 points closer together. And as we did that, that becomes the derivative, or the instantaneous rate of change, which is the slope of the tangent line at that given point. There were many ways that we represented it, but in the classroom, we focused on using the definition of the derivative. So this is one thing we're going to kind of review in a minute. Where f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x over h. Then after we had our practice with the definition of the derivative, we went on in the classroom to utilize many different methods. And these were our shortcut methods. And the first one was when we had something raised to a power, right? We called this the power rule, where we bring the power down in front, multiply by any value that's there, and subtract 1 to get the new power. Then other methods we introduced in the classroom were the product rule, the quotient rule, and the chain rule. Okay, so I know it's kind of hard for you guys to understand the notation, and we'll deal with that later on after your final, and we'll deal with that a lot next year. Right now, if you know just the product rule is the first times the derivative of the second plus the second times the derivative of the first. Our quotient rule can be found bottom times the derivative of the top minus top times the derivative of the bottom over the bottom squared. And our chain rule is the derivative of the outside times the derivative of the inside. We're going to take a look at a couple of the questions on our review sheet now. Okay. First, I want to review with you guys how to find the derivative using the definition of the derivative. To save time, I'm just going to do a nice easy one. So if I need to find the derivative of this, x squared minus 4x, I know you guys all know how to use your shortcut method. You would get 2x minus 4, okay? But for your final, that's not going to be good enough. If I ask you to use the definition of the derivative, it means I want you to show this work. I want you to show the derivative function can be found by evaluating the limit as h approaches 0 of f of x plus h minus f of x over h. So now we're going to take our original function and put it into this format. If f of x is x squared minus 4x, f of x plus h is going to be x plus h squared minus 4 times x plus h. Then I'm going to subtract f of x all over h. Next, I'm going to expand and simplify this numerator. So I have x squared plus 2xh plus h squared minus 4x minus 4h minus x squared plus 4x. And I can go through and I can cancel, and my new numerator becomes 2xh plus h squared minus 4h all over h. Remember, we're evaluating this limit. I still have to go through and do one more thing before I can h minus 4. Your h's cancel. Now when I plug 0 in for h, I get 2x minus 4. And this becomes the rule I can use to find the slope of the tangent line at any given point. And if you notice, it matches what we got using our shortcut method. So we are good. On your own, you can practice the other. Notice we have some different functions here. It might take a little algebra work, okay, but you should be able to do it. And then, you can very definitely expect to see just some general shortcut methods. So I'm just going to review a few of these off this review sheet to help you understand. So I have, let's say, number 6. F of x equals negative 3x cubed minus 6x to the negative 2 plus 4x. So basically, instead of using that definition of the derivative, if I don't specify that, you can just use the shortcut method. Negative 9x squared plus 12x to the negative 3rd power plus 4. Now, I just want to remind you, I may ask you to write your answer with positive exponents, in which case you would finish up by expressing your answer like that. Let's look at another. If we take number 9. Now here, when I look at my original problem, I have to remember that I can't take a derivative of a radical sign. So before I start this problem, I have to rewrite and then the best bet here would be to distribute. Okay, you could use the product rule, but that's going to make a mess of things. So here I would just take one last rewriting step. When I multiply like bases, I add their powers. And now I have it in the proper form where I can go ahead and take the derivative of this function. So now notice what I do. I write the notation for the derivative, f prime of x equals 1 minus 1/2 times 8, 4. 1/2 minus 1. So 1/2 minus 2/2, negative 1/2. Now here, there's two ways we can express this answer. I could expect you to just write it with a positive exponent, or you could go ahead and take and put that and write it with your radical sign. Okay, but those directions will be specified in your exam, how I want the answer. Either one of these is really correct. Let's take a look at another one. Let's see what's a good one to do. If we look at this, you could use the product rule there, or you could distribute, so I'm not going to worry about those. Same case here. That's your choice. Number 14. Number 14, we're going to want to use the quotient rule. So number 14, we're going to go ahead and we're going to use our quotient rule. There's my top, there's my bottom. So my derivative function, y prime, is the bottom function times the derivative of the top minus the top function times the derivative of the bottom over the bottom squared. Now remember, when we clean this up, we want to kind of clean up the numerator. So I'm going to have 21x plus 18. And over here, I get 21x plus 14. But remember, I'm subtracting this. So I have minus 21x minus 14. I have to remember to subtract the entire quantity. And I told you guys not to worry about the denominator. You can leave it just like that. And if you notice here, these guys are going to cancel out. 18 minus 14 is 4 over 7x plus 6 squared. And that would be the answer. Okay, moving on. I'm going to do one more example on this page. I think 16 is a good representation of the chain rule in like its most basic form, and then you can practice the other chain rules. Remember, the way you're going to recognize when to use the chain rule is when you have some quantity being raised to a power. Okay, so we have to do the derivative of the outside and then take the derivative of the inside. So I'm just going to take the derivative of the set of parentheses, 3, leave the inside alone. 3 minus 1 is 2. Now I'm going to take the derivative of the inside. Now I have 12x cubed plus 6. And a lot of times I'm going to expect you to take, since now these are easy to work with, I would expect you to go and clean that portion up. So this is 36x cubed plus 18 times 3x to the 4th plus 6x minus 2 squared. Okay. So that would be the correct answer. Notice the parentheses because that is a binomial. I multiplied those things out. So I guess that's really all I expect you to be able to do for your final when it comes to using derivative rules. Notice down here, ignore these. These are just too hard. Okay, and I also want to point out that there's no trig derivatives on your final. Okay, I'm sticking with basic algebra type problems because again, you're going to have enough trig on your final, and I don't want to overwhelm you. Okay, so signing off. So long.